5, 4, 3, 2.
I know, you see, somehow the world will change for me and be so wonderful.
Well, the world is going to be wonderful again, everybody. You'll see. You guys have been really patient, hopefully following all the rules, and when that happens, we'll get back to where we're supposed to be, our wonderful world again. If you don't remember, that was the iCarly theme song that I started with at the beginning of our interim learning, and that I am ending with at our interim learning. When you think of iCarly, think of me. All right, well, this is our day 3 of our solving polynomial equations. And before we start solving polynomial equations, I want you to know that we are going to, you start writing these notes, of course, that the part 1 of our homework will have us use the discriminant to find the number of solutions in a quadratic equation. Quadratic equations are really special to us, everybody. We can do them through a number of ways, even 2 methods which you haven't learned yet, but you will learn in Algebra 2. The only method we have been solving quadratic equations is through the zero product property. I'll put that up here, zero product property and quadratic formula. A quadratic formula can only be used on quadratics, by the way. But we started talking about discriminants too, if you remember. And if you remember what the discriminant is, it will tell you, sometimes it'll tell you if you can factor a polynomial. But now we're going to see if the b squared minus 4ac tells us we have a solution to a quadratic equation. So there are only really 3 things that can happen with a discriminant. Your discriminant could be positive. You should be writing this down. And if your discriminant is positive, that means the equation you're trying to solve has 2 solutions. What else could your discriminant be besides positive? It could be negative and it could be 0. Well, what if it's a 0? If your discriminant is negative, then you take the square root of the 0, it's 0, and you'll find that you'll only have 1 solution. And if the discriminant is negative, then you will find that you will have no solutions. We'll say no real solutions, because when you hit Algebra 2, you'll see that you'll have some solutions. You'll just call them imaginary solutions. I know that sounds weird, but you really are going to have imaginary solutions. So let's just find the discriminant to this. If I found the discriminant to this, I can tell you how many solutions I'm going to have. So I'll do b squared minus 4ac. So negative 5 squared minus 4 times 10 times 3. By the way, the negative, when you square it, make sure that even if your calculator does it as a positive, as a negative, it's really positive. It's because you had to wrap parentheses around it. So it looks like 25 minus 120, which gives us negative 95. So since that discriminant is negative, it has no real solutions. And you did this on an IXL in, I think you only had to get an 80 on it or something. So anyway, that's going to be part 1 of tonight's homework, also part 1 of what you're going to have on your quiz when I assign your quiz on Monday, okay? So learning about the discriminant, whether it's positive, 0, or negative, and what could happen to it. Okay, so we're going to continue to solve. We're going to solve some harder problems on day 3. So I can ask you to solve, and if I say solve through any method that works, you have to know if you can use, again, there's ZPP or there's quadratic formula. There are 2 other methods, you just haven't learned them yet. So when you're going to solve this one, you have to ask yourself, is it quadratic? Quadratic means the second power. Means you can't use quadratic formula for this one. So CPP wants you to factor this. So let's factor this, and when you see more than 4, more than 3, you know you have to factor it by grouping. So when we factor by grouping, we make it plus the opposite, and then we can group them. And again, we're still going to have to solve these though. So let's start by factoring them like that. By the way, don't forget, when you always think about how many solutions you're going to get, always look over here. You're going to get 3 solutions. So at the bottom of this page, I want 1, 2, 3 solutions. So So out of here, when I factor by grouping, I take out a GCF of x squared, and I get 2x minus 3. Over here, I take out a GCF of negative 25, and I still get 2x minus 3. So then I am going to, did I take out a 50 or a 25 here? 25. So I take out my 25. So when I take out that 25, I have 2x minus 3 left, and then I have an x squared minus 25 left. That can continue to factor. So I'm going to say 2x minus 3, and I'm going to factor this further, and I'm going to get x minus 5 and x plus 5. And that will equal 0. So remember how I said I wanted 3 solutions? 2x minus 3 equals 0, x minus 5 equals 0, and x plus 5 equals 0. So I'm going to show my solving on all of these. If you don't get full credit. So my first solution is x equals 3 halves. On this one, I'm going to add a 5 to both sides, and I'm going to get x equals 5. And on this one, I'm going to subtract a 5 on both sides, and I'm going to get x equals negative 5. So those are my 3 solutions. Now, if it doesn't factor further, something has to occur that you have to continually do. So I'm going to show you that on the next one. So see how you have 3 solutions? 1, 2, 3, because you factored. So say you had to factor by grouping, and you got 2x, it's very similar, 2x cubed minus 3x squared minus 50x minus plus 150 equals 0. Or we'll say 100 on this one, 100 on that. So it's very similar, but a little thing happens at the end that is a little bit harder for you, and I'll show you what that is. So I'm going to factor out my x squared here, and I'm going to get 2x minus 3. Over here now, what can I pull out of 100 that I can pull out of 50? I can pull out a minus 50, and then I get 2x minus 3, and that equals 0. Now what happens here is I get x squared minus 50, and over here I get 2x minus 3. The problem with that is you can't factor that any further. And if you remember, you need 3 solutions because of that to the third power. Well, this one's easy enough. We did it in the last one. It's 3 halves. But so since you can't factor that anymore, you have to set that equal to 0, just like you set that one equal to 0. So now you have to think of another way to factor that, to solve this. Since it is quadratic and it doesn't factor, you can do this one through the quadratic formula. I mean, you've done something like that through the quadratic formula, so why not do this one? So A is equal to 1, B is equal to 0, C is equal to negative 50. So x equals the opposite of 0 plus or minus b squared minus 4 times a times c all over 2 times 1. So that gives us negative 0, well, just 0, plus or minus the square root of, what is that? 0 minus a negative 200. So it's 200 over 2. So that gives you positive square root of 200 over 2, negative square root of 200 over 2. And now you just have to find the square root of 200, which is 14.14 over 2, negative 14.14 over 2. So the decimal version of this is 7.07 and negative 7.07. So here are your 3 solutions: 7.07 rounded to the nearest hundredth, negative 7.07, and then the 3 halves. Because this one did not factor further like this one did. See, that one factored further, so you can solve it through zero product property, This one you did, and these 2 you did, but in this case you can't, so you better take the quadratic formula. You're going to have problems like this on tonight's homework, and of course the quiz too. All right, next, next is going to be some problems that are similar to the ones you saw in your quiz. Again, if you were asked to solve and you said, can I do it through ZPP or quadratic formula, you have to first see if it factors or if it's quadratic. Well, I can tell right now it's not quadratic. Quadratic means to the second power. So you're going to have to factor this. So the GCF is x. X squared minus 144 equals 0. And by the way, don't forget 3 solutions here, right? Because it's to the third power. So this factors further. X minus 12, x plus 12 equals 0. So you do x equals 0, x minus 12 equals 0, x plus 12 equals 0. So here your solution is 0. Here you add 12 to both sides, and the solution is 12. And here you subtract 12 from both sides, and the solution is negative 12. So again, it has to be quadratic if you want to solve it through the quadratic formula. This is to the third power. So sometimes it won't be equal to 0, so you will have to make it equal to 0. And also this is now quadratic, so not quadratics to the third power, so you have to do ZPP. If you find a quadratic within it, I'll show you that you can use the quadratic formula within it. So I like to have my lead coefficient, my highest degree, positive, so I'm going to add x cubed to both sides and put it in descending order. So now I have it equal to 0, which means I can choose ZPP or quadratic formula if it's quadratic. So it's x cubed plus 15x squared plus 50x. So it doesn't look like it's quadratic, but it does look like it's going to have 3 solutions. So out comes the x squared plus 15x plus 50 equals 0. So just in case you wanted to do this piece of it through the quadratic formula, that's fine, as long as you realize x is equal to 0. And then you could do that through quadratic formula. I personally noticed that that one's very easy to factor. So x plus 5, x plus 10. So I do x equals 0, x plus 5 equals 0, x plus 10 equals 0. Subtract 5 from both sides. Subtract 10 from both sides. So now you have 0, negative 5, and negative 10. A lot of ZPP on that one though, because there was no quadratics for you. Okay, next, I think we only have 2 more to go for these notes, so it's a really short notes. It's a little bit longer of a homework, so that at least balances it for you, right? But the homework's pretty important because it acts like a review for the quiz. So here's a mistake that people make. This one is very easy to solve because it's factored and equal to 0. This one's not as easy as it looks to solve, because even though it looks factored, it's not equal to 0. So remember on this one, you can't say x plus 5 equals 60 and x minus 6 equals 60, because it's no such thing as the 60 product property. You can do it to this one and say x plus 5 equals 0, x minus 6 equals 0. This is such a nice one because it's already factored for you. See that? And so your solutions here are negative 5 and 6. But your solutions here are not negative 5 and 6, nor are they the 5 that can subtract from the 60. So what you need to do on this one is you need to subtract the 60 from both sides. Now when you do that, don't subtract it from the 6 or the 5. You have to multiply out the 2 binomials. So you get x squared minus 6x plus 5x minus 30, and then there's that minus 60, and it equals 0. So now you get x squared minus 1x minus 90 equals 0, and now you're going to factor it again. You thought it was factored for you. It was, but not equal to 0, so you have to kind of do a refactor of it. So now you get x, I factored x minus 10, x plus 9, so you get x minus 10 equals 0, x plus 9 equals 0. You add the 10 to both sides. You subtract the 9 from both sides, and you get a 10 and a negative 9. And if you want to know if that works, you pick one of them to plug in and see. You can plug both of them in, but one at a time. So you go back to the original, say I'm going to plug in 10. Let's see if it works. 10 plus 5, 10 minus 6, does it equal 60? So 15 times 4, yep, it equals 60. So we know the 10 works. You can try the -9 at any time. So tonight's homework is a worksheet that also is going to act as a review for your final quiz. So make sure that you know it inside out, and when you get the answer key, correct it. So that is going to be your homework for the weekend. I'm assigning it. This last problem, I did the last 2 problems. And your homework tonight is going to be a worksheet. I'm assigning on Thursday, and it'll be due Monday. Monday I'll assign your quiz, and it'll be due Thursday. Guys, I'm not taking any extensions after Thursday, and I don't want you to even mess with that deadline because I'm just not taking anything after Thursday of next week. So have a great weekend. Talk to you soon. Well, not really. Bye.